Hey everyone, thanks for coming. I'm gonna wait a few minutes to let any latecomers join so they don't miss anything. But if you're here for the Intro to Web3 webinar with Consensys Academy, you're in the right place. All right, so while we wait for the rest of the people to join, I just want to direct you guys to our Consensys Academy learning platform at learn.consensys.net. We have two courses that are related to the topics that we'll be covering today in the Intro to Web3 webinar. We have our Blockchain Essentials course, which is a definitive introduction to blockchain technology and Ethereum specifically for anybody, technical and non-technical audience. And we also have a blockchain developer program on demand, which provides motivated developers all the necessary content, tools, and tips to build their Ethereum knowledge and development skills. So that's the blockchain developer program will go into a lot of the concepts and topics that we cover in the webinar today. So yeah, I'll just get started. All right, so we're all here for the Intro to Web3 webinar. My name is Josh, and I'm a technical trainer with Consensys Academy. I help manage and support the blockchain developer program on demand, as well as our bootcamp program. So if you decide to take one of our programs, I'll be helping you guys learn this material and how to be successful developers in the Ethereum space. So just a little bit about Consensys and Consensys Academy. Consensys is a global blockchain technology company building the infrastructure, applications, and practices that enable a decentralized world. Consensys Academy is the education partner for individuals and companies to develop their business and technical skills that leverage blockchain technology. And as I mentioned earlier, you can check out all of our offerings at learn.consensys.net. And we have the two courses that I mentioned, but we have many more. All of the webinars that we produce, we post on our website for free, so you guys can see the topics we've covered in the past. And I just want to shout out to a webinar we did recently. If you're a professional looking to move into the Web3 development space, we have a Web3 jobs webinar where we talk with Jason Yee from Consensys Hiring and Talent, Thomas Rush from Consensys Labs, which is an investment arm of Consensys, and some Academy alumnus for that graduated in the developer program last year, and they're currently working for Truffle. So I have a link to the webinar there. We'll share the deck after the webinar, or you can just go to learn.consensys.net and find the course there. So in this webinar, I'm going to be talking about Web3. Web3 is an umbrella term for kind of the next phase of the internet. It's a lot of the like bleeding edge technologies that are currently being developed. And blockchain technology is just one of these areas where this development is taking place. Blockchain technology is just one aspect of Web3 development. So I just have a disclaimer here. I'm going to be talking about Web3, what it enables, and how it's different than the traditional web or Web 2 or Web 2.0, as it's commonly referred to in the space. And I'm going to be talking about Web3 with a specific focus on blockchain and Ethereum and what these technologies enable and what they can do. There are components of Web3 that I will not cover here, but many of the projects working on Web3 and many of the primitives and development practices relevant for blockchain technology and Ethereum specifically are relevant for Web3 generally. And we'll get into those details as we go through the webinar. I also want to mention I will not be covering everything that Web3 enables. This webinar is just a preview of what is possible with Web3 and how it works and what a possible future might look like. As I mentioned, this is the bleeding edge of web technology development, and research and development is happening in more ways than I can keep track of. It's a vibrant ecosystem, and there's a lot of cool things happening. And this webinar just provides an overview of what I'm familiar with and what I find interesting. So with that, just an overview of what I'll be covering in this webinar. I'm going to talk about what Web3 is good for and like why we should all care about what's happening in the Web3 space, why it's cool and some interesting problems that it solves. I'm going to cover some basics about how Web3 works in terms of like the network architecture, how the peer-to-peer networks work. I'm going to touch on how account management is pretty significantly different in the Web3 world than it is in the traditional web space as it is today, where big organizations are managing accounts for us. I'll touch on smart contracts, what they are and why they're cool. And then I'll introduce you guys to some Web3 tools. So whether you're a developer or a non-developer, I'll show you guys some things that you can install and explore to start playing in the Web3 space and seeing what's available. So what can Web3 do and why should we care about it? As I mentioned, one of the components of the Web3 world is blockchain technology, which was really like a breakthrough in how users like share and update data in a secure and reliable way. Blockchain technology really allows users to create, trade, and record scarce digital goods in an open and public system. The first well-known use case of this is the development of global permissionless digital cash with the development of Bitcoin. And the white paper was published in 2009 for Bitcoin. This is slightly different than in the Web 2 world because in the Web 2 world, scarce digital assets are possible. Think about banking, online stock trading platforms, or any asset management system. But with the development of blockchain technology, this is the first time we have completely open systems where we don't need to create accounts with organizations first. These are really like user-controlled accounts in completely open systems, which is a real innovation. This creates massive opportunities for application developers, and it allows for innovation in previously impossible ways, especially related to financial products, which we'll get into a bit later. And we see this in the emerging decentralized finance world that's being built on Ethereum, which has really taken off in the past year. So in addition to this scarce digital asset aspect of Web3, there's also Identity is a huge part of the Web3 world, where users are owning their assets. They're acting in a self-sovereign way where they are really the owners of their actions, and this has implications for governance. What enables these new forms of identity in the Web3 world are new cryptographic tools that are becoming much more popular in the web. We're building a much more robust identity infrastructure that will create a more reliable identity layer in the web. This has been something that's been lacking in the internet as we know it today in traditional Web 2. We defer account management and identity management to organizations like Google or Facebook, or in terms of financial assets like our banks. These reputation and identity systems are hackable, or they're closed systems which rely on these organizations that I mentioned. And these companies can mediate our online identities and remove us or ban us or censor us as they wish. We really have to trust that they're acting in our best interest. We don't have much control in this regard. Yeah, these robust identity systems also allow for new forms of reliable open governance, because we can more securely and reliably track users' participation and reputation. When we have guarantees around how identities are available and managed in the system, we can have more trust in those systems that are built on top. It's hard to imagine building a governance structure on top of a Facebook identity layer when Facebook can just remove users as it wishes. You guys may have heard about the term decentralized autonomous organizations, or DAOs. This is just one type of new organization that has really taken off in the past year and has been made possible by this new identity layer that's being really built with in the Web3 world. So a result of this is just building a more resilient, user-centric internet. The result of the ability to reliably track and trade scarce digital assets and have a built-in robust identity management system allows us to have a more resilient and user-centric internet. You may have heard about some of the difficulties around some of these new foundational tools in the system. You may have heard about smart contract hacks, or people losing millions of dollars in blockchain systems, or just value getting locked and no longer being accessible, or people losing their private keys associated with accounts that are holding large sums of cryptocurrency. But building this new, really foundational internet infrastructure is not easy, and unfortunately the hiccups along the way can be expensive. But this is something that we've seen in really the development of the internet the first time around. It's just that this time we're building a value layer built right into the internet. So the consequences can feel a lot higher. But research and development is ongoing, and it's getting easier and it's getting safer. So I want to dig a bit deeper into the Web 2.0 versus the Web 3.0 world. Really, what is the underlying infrastructure that's supporting the shift that we're seeing here between Web 2.0 and Web 3.0? And just an overview of what I'm going to be talking about. I'm going to talk about how the network has changed, how we're building in different network architectures, how account management is different, how we can think about distributed computing in new ways, and how these differences between networking accounts and distributed computing allow for new capabilities and new patterns that were previously not possible. So just a refresher, on networking and the internet today. Um, when the internet was first designed, it was kind of thought of as like it would be a mesh network where internet users are hosting websites on their personal computers in a peer-to-peer style network, and everybody's sharing information they would like to publish and reading information off of each other's computers. But this is very different than the internet architecture that we see today. Um, just to improve efficiency and availability of websites and content that people were publishing, they started using dedicated servers to make websites available. And this like set the stage for the Web 2.0 internet model that we see today, which is just a client server relationship. Many of the problems that we see with this client server model in terms of data breaches, corporates profiting off of data provided by users. We often forget that internet services that we take for granted would not be available without these developments in like the client server architecture. But we're getting to developments in hardware and software that are allowing us to really change the way the internet is architected at a fundamental level. This client server dynamic sets up a natural asymmetry between computers that are storing and serving information and the computers that are accessing the information. So servers in the network, which are storing and serving all the information on the internet today, are single points of failure. They're single points of trust, and they're honeypots of information for hackers. Even if hackers aren't maliciously getting into servers to steal information, we've seen instances where people managing these servers accidentally leak large amounts of information. And in systems where we don't have these large single repositories of this data, these mistakes are less likely and less disastrous when they do happen. And as users in these systems, we have very little say in what actually happens with our data. We have to trust that organizations like Facebook and Google are not selling our personal information for malicious purposes. So this is the Web 2.0 world. In the Web 3.0 world, we're seeing more of a peer-to-peer style network. Peer-to-peer networks are more similar to what the original vision for the internet was, where individuals rather than organizations are communicating with each other in a mesh network. These peer-to-peer networks are more redundant and resilient. They are a bit less efficient than client-server networks and network architectures, and they require better internet connections and better user end hardware to achieve the same performance as client-server networks. So it makes sense that we're seeing a trend in this direction today. In peer-to-peer networks, every computer is running the same software and can be considered an equal in the system. All computers have equal access to store and share information with all other computers on the network, and connections between these computers are not necessarily routed through central server computers. All computers are storing information that is relevant to them locally on the user's machine, or it can be easily retrieved from any number of peers. So this removes the requirement of having a central server database where all computers are going for the same information. And these peer-to-peer networks have much greater resiliency than client-server networks. There's no single point of failure in the network. So a significant number of nodes can go offline and the network will continue to function normally. Whereas in a client-server architecture, if the server or a small number of servers goes offline, the service provided by the network breaks for everybody. By storing and routing information through this peer-to-peer network and using cryptography for managing user access control rather than a central database of user data. This type of network can provide the same level of service as a client-server architecture. One of the big difficulties associated with this is maintaining a public key infrastructure to handle access control. But significant progress has been made with the rise of blockchain technology because it's provided a massive incentive to solve this problem. And in practice, we see kind of a merging of these two network architectures in services like Infura, which provide a traditional style API access to peer-to-peer network infrastructure. So we can get the convenience and ease of accessing a central database, but it's behind a API service like Infura. We're still deferring trust to these systems, but it's not a requirement to participate in these systems. So it's a different way of thinking about how we trust the services that we're using on the internet. So this gets into the account management aspect and the differences between Web 2.0 and 3.0 here. In traditional web, the websites and organizations are typically responsible for saving and handling user data in a responsible manner. And as you all know, this means having users create an account or sign in using a third-party authentication service or signing up with an email and password. And once users sign in, websites typically start collecting data about them to provide better services or sell it to other organizations and as advertising. This model presents a slightly risky situation for leaking user data, but it's very convenient for users. So it has definitely been integral in making the internet as easy and usable as it is today. In a Web3 world, users own their accounts, and accounts are independent of any application or service. And these accounts are built on cryptography and secured with complex math. So the cryptography backing many of these accounts in public blockchain systems today secures, I think, over $200 billion in public blockchain assets as of when I looked at it yesterday. So this cryptography is very secure. If anybody could break any of the cryptography underlying the accounts here, they would be able to essentially take off with any of these blockchain assets that they please. So with these cryptographically generated accounts, these systems allow users to digitally sign messages and verify their identity for things like value transfers or to grant permissions to specific applications. It also allows users to encrypt data and send it across a public network and allow only certain people to access the information. You may have heard about blockchain wallets that are used to store and manage blockchain assets. Wallets can be thought of as a sort of keychain, a cryptographic keychain where you're actually holding your keys with the wallet, and that wallet is just allowing you to manage the keys associated with the type of account on your blockchain wallet. MetaMask is a great example of a Web3 product that provides account management services. So now we'll talk about blockchain as a global database, which incorporates the networking layer as well as the account management layer. You can think of blockchain as a sort of distributed, trustless global database. It's a database with a networking protocol built into it at a fundamental level, with the secure account management provided by cryptography and the wallets. This allows for capabilities that were previously not possible. The The first application of this technology at scale was Bitcoin, which is just a simple database of accounts and values with the capability of updating the database according to the protocol rules. Namely, increasing the value of one account must correspond with the decrease in value of another account. So it's easy to see how a system like this could become a global ledger of value and act as a digital cash system, especially since this is a public open blockchain network that runs on free open source software. So anybody with a computer and an internet connection can join the network and start sending transactions without any external approval. So we have some advances in this blockchain as a global database idea with the development of Ethereum. Ethereum is really using blockchain as a global computer. It builds on and extends the same principles that make blockchain as a global database possible. And you can think of, if Bitcoin is a networked database, then Ethereum is a networked virtual machine, which just means there's a distributed ledger that tracks the value that's associated with accounts, but there's this additional component of programming logic that allows small programs to be executed on the blockchain in the same trustless, reliable, available manner as well. This addition of programmable transaction logic increases the power and the capability of blockchain by orders of magnitude, I would argue. And it also increases the complexity and the difficulty of developing secure, reliable programs on the blockchain. We're going to touch on some ways that we can think about developing applications in reliable, secure ways with this increase in complexity as well. So these small programs that are running on blockchain are often referred to as smart contracts. Smart contracts are just programs that are stored on the Ethereum blockchain. And generally, it's across all blockchains or all protocols. A smart contract is considered to be a computer protocol that is intended to digitally facilitate, verify, or enforce the negotiation or performance of a contract or a program in this case. And smart contracts allow for the performance of credible transactions without third parties. So this is one of the big breakthroughs in putting a virtual machine on a blockchain, is we can have users download the Ethereum software, connect to the Ethereum network, and start making transactions on this network without relying on any third party. These programs, these smart contracts, can manage the cryptocurrencies of their underlying blockchains natively and easily interact with the accounts and other smart contracts on the blockchain. This feature of trustless, easily programmable money on an open public system is a completely novel invention, and it's considered by many people to be revolutionary. So with these programs that easily handle value of the underlying blockchain, it's really a useful way to think about it is really being programmable money. So I want to talk a bit about some of the unique things about smart contracts, because smart contracts are living in this unique blockchain environment where the rules of programming are a bit different, and it requires a bit more understanding about how the underlying blockchain technology works. We're not going to get super deep into the details of the differences here, but I just want to highlight some of the differences that developers and users need to be aware of when transacting or interacting with smart contracts. So a big thing in this is blockchains are an asynchronous environment with potentially long wait times for transactions to settle. Um, Users today are currently very used to instant, um, fast internet experiences, and wait times of upwards of 10 minutes for like a single Bitcoin transaction to process can be super frustrating for new users if they're unfamiliar with what's actually going on behind the scenes and how the technology works. So, as a user, it's very important to understand basically the constraints of the system to manage expectations. And as a developer, having clear messaging around this is very helpful to make user experiences better. It's something that needs to be negotiated along the way, and sometimes it just means providing more information about what's actually going on. Um, Additionally, for developers specifically, um, there's entirely new programming languages being developed since Ethereum has a unique virtual machine. They're unique programming languages specifically for writing smart contracts on Ethereum. This is really only a minor hurdle to getting started with developing applications. Um, I'd say an experienced developer can pick up Solidity or Viper and start writing smart contracts in less than an hour. Um, but learning all the nuances and the gotchas associated with developing smart contracts on Ethereum, um, it takes much longer. And fortunately, there's a robust developer ecosystem in Ethereum that makes acquiring the necessary skills relatively easy. And I'll provide some resources to some good, um, I'll provide some links to good resources later in the presentation. Another big consideration when developing or interacting with smart contract systems is there's really this pay to play aspect where there's a cost of performing any action in this global system, and you need a you need value in your account before you can actually do any interactions from that account. So this presents a big challenge around user experience, and acquiring having a user acquire cryptocurrency to pay for these transactions is not a trivial task. It causes a lot of friction when app developers are trying to onboard new users, and without onboarding new users, it's really hard to launch a successful product, obviously. Um, but this is an area of active research in the Ethereum community, and the programmability of Ethereum allows developers to create systems where developer or organization accounts, specific designated accounts, can pay the transaction costs for new users, or you can just delegate payments of transactions to other accounts. So this is kind of an advanced solution, but it's definitely something that needs to be considered when you're interacting with new applications or developing applications yourself. This is something that's definitely unique. And the last thing I want to touch on here is there's just a very high cost of failure in developing on blockchain specifically, as opposed to just in a traditional Web2 environment. Um, in traditional web development, you may have heard the mantra move fast and break things, where you should always be shipping new features and updating products and fixing bugs later. But this is definitely not the case with smart contract development. Smart contracts, once they're deployed onto the blockchain, cannot be upgraded or changed unless they're specifically programmed to do so, which just adds more and more layers of complexity as you add functionality to any smart contract. And you may have heard of some famous failures on Ethereum due to improperly coded smart contracts. For instance, the DAO hack in 2016 resulted in upwards of $50 million worth of Ether being drained from a smart contract, and it resulted in a split of the community. Ethereum Classic is the result of a disagreement in how to handle this smart contract bug. You also may have heard about the parity wallet bug, where an incorrectly protected function resulted in hundreds of millions of dollars being locked on Ethereum. And all of these mistakes are preventable. Avoiding them just requires knowledgeable developers and good software development processes. So fortunately, there are many projects in the Ethereum ecosystem whose sole mission is to make writing secure smart contracts easier. And I'll provide some links to those shortly. So here I'm sharing some tools with you guys on how as even a non-technical user, you can start using Web3 specifically as it relates to Ethereum. How you can start using it today. Yeah, as I mentioned, MetaMask is a great tool for connecting to the Ethereum network without having to run the Ethereum software. And you can start transferring your Ethereum-based assets and interact with smart contracts all directly from a Chrome extension. So it's super easy to install, and I highly recommend it to everybody if you haven't tried it yet. Once you have an account management tool, you can start interacting on decentralized exchanges where you can trade your Ethereum assets in an open market or through a smart contract controlled system. So AirSwap is a exchange marketplace, and Uniswap is a smart contract designed exchange. And both of these examples are they provide great examples of what a good user interface is, how they can be user-friendly, and they do a great job of explaining what's going on throughout the process as a way of managing expectations for users and how users can interact with the application and how the application should actually behave. So those are great apps that I recommend you guys check out. Also, if you're interested in running an Ethereum node, which is just running the Ethereum software and running it on your local machine so you can connect with other participants in the Ethereum network, the Ethereum Foundation just released this tool called Grid. You can find it at grid.ethereum.org, and it's just an application you can download, and you can choose which client software you'd like to run, and this will take care of the installation and configuration for you and start syncing everything. This is cool because you don't have to trust anybody to provide you with the latest blockchain data or send transactions for you. You can just do it all directly from your computer. And as I mentioned earlier, one of the cool things that's being developed on Ethereum now is this decentralized finance ecosystem. The decentralized finance ecosystem provides services to cryptocurrency holders that have been traditionally reserved for banks and financial institutions. You can use an application like Compound Finance to borrow crypto assets by posting collateral, or you can lend your crypto assets to borrowers and earn interest on those. So this is a very interesting and active area of development in Ethereum, and I think, yeah, check it out. Just touching on some of the developer tools that are unique to the Web3 space, specifically Ethereum. When you're building a blockchain application, as I mentioned, there's fees associated with transactions on the Ethereum network. So using virtual blockchain simulators or test nets that aren't handling real assets to develop applications is essential. Common software to do this includes Geth, which allows you to connect to the main network, any of the test nets, or run a development chain, as well as Ganache, which is a product built specifically for Ethereum smart contract development and testing. It comes with a nice user interface and makes inspecting the state of your development chain much easier and provides advanced features. And as I mentioned before, Infura allows you to connect to the Ethereum network just with a set of API keys. So you can develop on a testnet using Infura or actually do mainnet deployments right through Infura. And specifically around smart contract development, the Remix IDE is a browser-based IDE that doesn't require any installation of software, and you can use it to write Solidity or Viper smart contracts, compile the contracts, deploy the Ethereum code to the network, any of the test nets or development chain that you're running. It includes some basic security and debugging tools, and it's super convenient because you just go to remix.ethereum.org and you can get started. As I mentioned, security is a huge consideration, especially for smart contracts that are handling lots of value. Consensys put together a definitive guide on smart contract development. I have it linked to here. I'll share the deck with you guys after, where you can link to it. But this guide covers a general approach to smart contract development, overviews of known attacks, token-specific recommendations, software engineering techniques as related to smart contract development, and security tools and improvement proposals. And I just want to touch on the Truffle development framework because it's probably one of the most popular development frameworks for smart contract development, which just makes contract deployments easier, and it also makes testing very easy, which is a super important part of smart contract development. And then just the Solidity documentation is one of the best resources for learning about Ethereum and Solidity. So just touching a bit more on developer tools. MythX is another Consensys project that came out of Consensys Diligence. MythX provides security analysis tools, so you can just run your code through like a static code analyzer, and it will help you find errors. There's really no reason not to use one of their static analyzers to check for vulnerabilities. And Consensys Diligence is the smart contract auditing arm of Consensys, so they do a great job of checking smart contract code before it's deployed onto mainnet. And I would say that any production project on Ethereum should go through a smart contract audit before it's actually deployed, just because the risk of failure is so high. And then Open Zeppelin is another project that has a lot of audited smart contracts that they publish publicly. So you can, if you're interested in developing a token, let's say, they have many token contracts published that you can just copy and use in your own projects. And if you're interested in learning more about anything that we covered in the webinar today, you can go to learn.consensys.net and look at the Consensys Academy products, or go to ethereum.org/developers. And there's a lot of great tools there. And just wrapping up, I want to mention that this is really an emerging ecosystem. There's lots of new types of organizations, new tools, new standards emerging in Ethereum, and continuous learning is really like an essential part of getting involved in any real way in the Ethereum ecosystem. We're seeing new types of organizations, as I mentioned, decentralized autonomous organizations, like Moloch DAO or DAO Stack. They're using DAOs to allocate funds, grant funding. So projects can join a DAO, and then they'll gain governance rights into how the funds of the organization are allocated. There's also token standards that are being developed and adopted, and you guys may have heard of the ERC20 standard or the ERC721 standard. There's also standards, token standards around security tokens, like I think ERC 1400 is creating a standard around how securities should behave and operate on Ethereum. And there's a process that's being used for basically improving Ethereum and rolling out these standards in a reliable and well communicated way. And yeah, just to reiterate, the ecosystem is changing rapidly. A good example of this is we have like the robust, thriving ecosystem of Ethereum 1.0, but there are limitations associated with the scalability of Ethereum 1.0. So Ethereum 2.0 is being actively developed, and the first phase of the Ethereum 2.0 testnet will likely launch at the beginning of next year. As of now, it's looking like Ethereum 2.0 is going to look substantially different than Ethereum 1.0. So it's going to require a different set of development tools and approaches. And as I mentioned, it's going to require continuous learning for application and smart contract developers, as well as leaders of development teams, which isn't really so different from traditional application development. But the fact that this ecosystem is so new, the pace of change is definitely faster than the traditional web space. And I just want to touch on the aspect of regulatory compliance as well. Since we are handling real value in these systems, this ecosystem is being subjected to more scrutiny by regulators than maybe the development of the internet the first time around. So having exchanges go through KYC processes like know your customer to prevent anti-money laundering is it's important for everybody to consider, as well as you guys may be familiar with the ICO boom in 2017 and the SEC fining certain organizations for selling unregistered securities. So if you are selling tokens on the blockchain, you need to comply with all regulatory laws, which wasn't something that was as considered in the past, as far as I know. So yeah, that's what I've got for you guys today. And I hope this was informative and helpful in helping you understand kind of where Web3 is, where Ethereum is, how it all fits in. And I think we've got about 13 minutes for questions if you guys have any.
So you can go ahead and drop the questions into the Q&A. There should be a Q&A button. Josh has some questions that have come in already that we're going to answer live. The first, how would transactions of smart contracts handle concurrency? And are they immune to deadlocks?
Yeah, so concurrency, there's really only one thread of execution on Ethereum 1.0 as it is today. So all transactions are processed sequentially. It's just the way that they're ordered in blocks. And then all blocks are verified by all participants in the system. So there aren't really concurrency issues because if a transaction runs into any sort of reverting error, it's just gonna fail. So yeah, there's just one thread of execution on Ethereum as it is today. For Ethereum 2.0 and what it's going to be like next year, I cannot say. I'll have to wait and see.
So our next question is, when we talk about Web3, do we only mean Ethereum or only public blockchains? What about permission blockchains? Are they a part of Web3?
That's a really good question. As I see it, I would say yes, just with the caveat that I imagine a future where a lot of private blockchains or consortium chains are going to have some sort of peg to a public blockchain, in the sense that even if it's just like a like posting of like checkmark data, like if you're just posting a hash of some data or posting a block status, I think we will see much more interoperability between public and private chains, and how private transactions on private networks are going to be backed by data that's published on public chains. I guess I guess there isn't really a strict definition of what Web 3.0 is, so other people might have differing opinions, but I think blockchain technology is really really falls in the Web 3.0 bucket, just because it is so new, and it integrates with this public permissionless user-owned ideals. So yeah, I hope that answers it.
The next question is, can we deploy our smart contracts on mobile applications? Love to have some insights on developing mobile dApps, which stands for decentralized applications.
Yeah, so you can definitely connect to the Ethereum network through a mobile phone or any mobile device. You're not going to be able to run like a full Ethereum node, so like the full Ethereum software on your mobile devices, but there is some development around running like light clients or like light nodes, which have they have less hardware requirements for connecting with the Ethereum network if you want users to connect to the networks themselves. Or you can also do all of these operations directly through services like Infura, where if you just have a set of API keys, you can connect to an Infura. You can connect to Infura, and Infura can handle all of like your contract deployments, your like reading the blockchain state or sending transactions, and that's not going to be any more demanding than any current Web 2 applications that you're already running on mobile.
Another one is, is the Ethereum ledger atomic? How does the Ethereum ledger handle atomicity?
So yes, the Ethereum ledger is atomic, which means every transaction that is broadcast to the network, either every state change associated with that transaction needs to successfully execute, or none of these state changes will successfully execute. So if there's any error, if any error is thrown throughout the course of a transaction being processed by the network, all of the updates made by that transaction will be reverted to the pre-transaction state.
Grouping together a couple questions, but there's some questions about, does Consensys offer free developer workshops, trainings to get experience developing blockchain dApps? And there's interest in knowing, how can someone basically like get in and test the water? Is it starting to use MetaMask in some dApps? Can you give any recommendations for either like getting started, potentially developing a proof of concept without having to do everything from scratch, and tools available to be able to do that, jumping in either from the user side or the developer side?
Yeah, great question. I think so I'm just going to preface this answer with kind of why I find web development generally so interesting, and why I like learning about it so much. There's a very interactive aspect to it that allows you to kind of like test and experiment and try new things very quickly and easily, and then also see kind of see what you learned, like just directly in the browser. You update the page and you can see how your code is affecting your application right there. which is that quick turnaround, I think, is really helpful. And I mentioned the Remix IDE in the presentation, and I think that's a great way to get started with contract development. It can be a little intimidating at first because there's a lot of stuff on that page, but it allows you to very quickly get started with writing smart contracts. You can compile your contracts automatically in Remix and then start deploying them to the network. I would say checking out the Remix documentation to go through one of the getting started pages is very helpful, just to kind of guide you through the first things first. Another great resource for developers is just going through checking out the Solidity documentation. Just because there are some inherent limitations with Solidity that aren't present in other programming languages, because you're developing in this unique environment. And the Solidity documentation does a great job of explaining why those limitations exist and kind of like why Ethereum is designed the way it is. So from the developer perspective, I think those two resources are essential. From just the user perspective, I would say install MetaMask. On MetaMask Mobile, MetaMask also has a mobile app. There's some recommended dApps that you can start trying right on your mobile device. But it's kind of, on my phone, it's kind of slow. If you go to stateofthedapps.com, there's like thousands of dApps on that page, and it's not just Ethereum dApps there, it's Web3 generally. So I think there's EOS applications there, Bitcoin applications. So if you have MetaMask installed in your browser and you go to State of the dApps, you'll automatically be able to interact with any of those applications. Like MetaMask will just handle your account management right there. So State of the dApps is a great place to explore new things that are being built on Ethereum and Web3 generally.
The next question is, what's going to happen with smart contracts, dApps, and tokens that were published or created using Ethereum 1.0 after the Ethereum 2.0 launch?
So there's definitely going to be some sort of upgradable path where you can go from a Ethereum 1.0 dApp to an Ethereum 2.0 dApp. It's not exactly clear what that looks like. In terms of migrating your Ether, which is the native cryptocurrency of Ethereum, it seems like it's just going to be a smart contract on Ethereum 1.0 that's being watched by Ethereum 2.0. So when an account makes a deposit into this contract, new Ether will be minted on Ethereum 2.0 with that same account, or to that same account. I've also heard discussions recently about providing the Ethereum virtual machine is the execution context of Ethereum 1.0. I think that the Ethereum virtual machine will also exist on Ethereum 2.0. So Ethereum 2.0 could have multiple execution contexts. The EVM could be one, like WebAssembly could be one. I've even heard like Libra, the move language could be an execution context in Ethereum 2.0. So if it's easy to imagine how contracts and like the current state of Ethereum 1.0 could exist in Ethereum 2.0 if the Ethereum virtual machine is an execution context there.
Great, and we're just at the top of the hour. We know that we have a bunch of more questions coming in. So what we'll do is we'll actually, in the next few days, we will be posting the recording to learn.consensys.net, and we'll answer and provide answers to all the questions that are asked. I just wanted to follow up on the fact that, there were some questions around what are the best way to learn? How can I get started? Learn.consensys.net has both free resources that are great ways to get started and point to other free resources as well. There are also classes that you can take. And if you stay tuned over the coming months, Consensys Academy will have more announcements on ways and initiatives to really help people get started and kick off, smart contract development, test the waters, and participate in this ecosystem. We want to thank Josh for giving us an overview of Web3 today. And we will be sending out, like I said, information on the recording, the slides. So all that will be headed to your inbox on how to access those in the next couple of days. And Josh, if there's anything else that you want to say before we close it down for today.
I just want to say thanks for coming. And if you guys have any questions and you want to reach out to me personally as well, my email is josh.krites, Krites, @consensys.net. So I'm happy to discuss any of these ideas further.
Thanks all, and thanks for attending, and look for more information from us shortly.